Good morning. Today my group would like to present about automotive component design and assembly, which is our title project radiator fan. Okay, in first slide we attach the YouTube link of our presentation. Okay, then second slide, the team members job scope. The first person is Rafish Dennis bin Rosli. His matrix number B0922105551. The task given for him is responsible for determining overall fan radiator design requirements and specifications. Conduct initial concept development, taking into account factors such as dimensions and design considerations. Creates 2D sketches and provides input on features, dimensions, and constraints required for components. Review and validate final 3D models and drawings to ensure they meet design requirements. The second one is Muhammad Aiman bin Abdul Ma'arif. His matrix number is B09221061. His job scope is converted fan radiator model to 2D production drawing using CATIA V5, translates 2D sketches into accurate 3D representations, taking into account details such as dimensions, features, and surface finishes. Creates detailed views, parts, and dimensions required for manufacturing and assembly. The third one is Muhammad Nur Aiman bin Muhammad Rashid. His matrix number B0922100205. His job scope is using CATIA V5 software to create a fan radiator design based on design specifications. Collaborate with other team members to ensure design aligns with project objective and constraints. Created exploded views and assembly drawings to showcase radiator fan integration. Provide input on design changes and assist in resolving and modeling challenges encountered during the process. The last one is me, Sarvesh Kumaran Anaki Ganesan. My matrix number is B0922100484. Performs quality checks on 3D models and 2D drawings to ensure they conform to industry standards and company guidelines. Review design specifications, dimensions, tolerances, and other requirements to verify compliance. Provide feedback and recommendations for design improvements, efficiency improvements, and standardization. The introduction. Computer-aided design, which is called as CAD software, such as CATIA, assists in designing and optimizing fan radiator to meet specific cooling requirements and maximize thermal performance. The best way to learn CATIA is by doing. Don't product designer. The objective. Using computer-aided 3-dimensional interactive application, CATIA, software program to design and build 3D models of fan radiators. Radiator fan is used in an effort to keep the engine cool. One of the unique aspects of our project is the development of a 3D radiator model with exact dimensions. We chose to use 3-dimensional computer-aided interactive application software CATIA as we learn how to build complex items. This is mean that if we have our own dimension or from other sources, we can use CATIA software to create an object by using the dimension into a 3D model or for an moving object. Then, what is radiator fan for? To regulate and remove the heat generated by the product's components or systems, preventing overheating and maintaining an optimal operating temperature. The fan radiator uses a combination cooling fins heat pipes and fans to facilitate efficient heat transfer. Fan pulls in the ambient air and direct it over the surface of the radiator, increasing convection, heat transfer and releasing heat to the surrounding environment. The importance of fan radiators cannot be overstated, as heat buildup can cause component failure, performance degradation, and even safety hazards. Radiator is important in maintaining thermal balance of the system, preventing critical components from reaching overheating temperature. With the advancement of technology, fan radiators have evolved to provide efficient and compact cooling solution.
Okay, now let's see how radiator fan work. Radiator fan work. He would use cool engine and electrical fan. The cool engine of a vehicle is does by the forcing air to flow through the radiator, which is a heat exchanger that transfer heat from the coolant to the air. The electric fan powered by the vehicle air system, while engine driving fan are powered by the engine itself. It way that a radiator fan work by the creating airflow through the radiator with the fan blade spin. Okay, this is the part of radiator fan. We have a radiator fan case, fan motor, screw and nut, and fan blade. Okay, now I will show you list of the component radiator fan. Fan motor is a function the motor fan in the car responsible for cooling the engine. It does this by circulate air around the engine, which help prevent the engine from overheat. Fan motor are usually powered by an engine, but they can also be powered by an electrical motor. How it works? The fan motor works with the following step. The battery supply power to the fan motor. The fan motor rotates the shaft with the connecting the fan blade. The fan blade rotates, which create a flow of air the radiator. The airflow help remove heat from the coolant through the radiator. Second, fan blade. The function of fan blade, a radiator fan, help cool the engine by blowing air through the radiator. In addition, it prevents the engine from overheat and help prevent dust accumulating on the radiator as well in improving airflow in the engine component. How it works? The fan radiator works with the following steps. Coolant flow through the radiator. Heat from the coolant is transferred to the air flowing through the radiator. The fan blows air through the radiator, which helps to rotate the heat transfer. The coolant then circulate back to the engine. Third is radiator fan case. The function of radiator fan case, the box is used to place the fan motor and radiator fan. How it works? Tighten the car screw or nut in front of the car engine so that the engine cooling system process in a good condition. The radiator fan case is an important part of the car system because it helps return holding the radiator fan and above missing component accidents. Nut, a screw and nut. The function nut and screw work to hold the radiator in place. Also help hold the radiator in place to prevent it from moving and help prevent leak from the radiator. It is a nut and screw on the car radiator become loose, it can cause the radiator to leak or move. This can damage the radiator engine. How it works? Here, how to tighten the nut and screw on the radiator. Use the ratchet and wrench that fit the size to tighten the nut and screw on the radiator. Tighten the nut and screw evenly prevent the radiator from warping. Okay, now let's see how the drawing is begin. We use two type of drawing. The first orthography and the second is isometry. The orthographic view is a two-dimensional representation of the three-dimensional object. The standard orthographic view are the front view, the top view, and the side view. The isometric view is a type of isometric projection that shows three dimensions of the object in two dimensions. Okay, now what the benefit of orthographic view? The first, presenting, provide a clear and choose way to represent the three-dimension object. Number two, dimensioning. can be used to show all of the important features of an object, including its shape, size, and dimension. Number 3, communicator can be used to communicate complex design ideas to others. Number 4, standards. They are a standard format that is used to many industries. What is the benefit of isometric view? Number 1, presenting. Provide a more realistic representation of the object than other type of isometric projection such as equilibrium projection. Number 2, dimensioning. Easy to understand and interpret, even for people who are not familiar with technical drawing. Number 3, communication can be created using a variety of software programs, making them a versatile tool in technical communication. And number 4, view can be created using a various software programs, making them versatile tool for technical communication. So this is the isometric view. We have a left view, front view, and this is the what we do. Okay, I'm done for now. I want to give to my friend to continue the presentation.
Thank you for those, my friend. My name is Aiman. Alright, as you can see, this is a design of 2D drawing from design of Femblade. They have 8 picture drawing. The first is section view, from view, left view, detail C, detail B, detail D, detail E, and the last is isometric view. And the next slide show, for example, we make 5 case of 2D drawing. The first is a detail A, detail B, right view, section view, in the back view, and the last is a bottom view. And as you can see, this is a isometric view, the scale of 1 and 8. And the third slide show, for example, we make fan motor of 2D drawing. The first is from view, back view, left of right view, and left view, and the detail A scale 1 and 1, and last feature show the isometric view. As you can see, what the number of show is, we make a specific design to make a fan motor in application Katia. And the fourth slide show, for example, we make screw and nut of 2D drawing. And the first is a nut. The show is a back view and a front view. The section view, the scale of 3 and 1. The number is we make for the specific design to Katya. And the screw 8, the show is a from view. The number is show to make a design the screw to Katya. And the last is a nut 10. The show is from view and the back view. The section view, the scale is 3 and 1. The number show the specific design or specific number to make the design to Katya. This is product of the we make Katya, a radiator fan. The first is an isometric view in shading with edge, and the second is isometric view in shading with material. As you can see, this slide shows a full of the predator fan assembly. The first is a back view and the front view and the isometric view. Exploded view. The exploded view is a type of technical drawing that shows the individual part of an object as if they had been exploded away from each other. This can be helpful for understanding how an object is assembled or disassembled, or for the visualizing how the different parts fit together. The benefit of exploded view. The first is a visual, can help to visualize how an object is assembled or disassembled. The second is presenting, can help to identify the individual part of any object. The third is communicate, can help to show how the different part of an object fit together. This is only I can show the present. Next, I will hand it over to my friend to present it.
Okay, so what is the exploded view? Okay, an exploded view is a type of technical drawing that shows the individual parts of an object as if they had been exploded away from each other, which is the product is being assembled or disassembled. We arrange it into one by one, piece by piece. All right. So this can be helpful for understanding how an object is assembled or disassembled, or for visualizing how the different parts fit together. Alright, so what is the benefits of exploded view? So, in visual, it can help to visualize how an object is assembled or disassembled. It is clearly can be seen each part is being disassembled or assembled to a product. Okay, to become a product. And then second, for presenting, it can help identify the individual parts of an object. If you have an audience, you can show it to them. They will understand and they will easily to identify the individual parts of an object. Alright, so for the communicate, it can help to show how the different parts of an object fit together. Alright, so which command we use in Kata to create the exploded view, which we can arrange it exactly what we want, right? So we can use the enhance scenes. Once you have created an enhance scenes, you can apply it to the assembly by clicking on the apply scene on assembly icon, which after we assembly, then we can run the enhancing command, right? Okay, for the exploded view. All right. So, what is the benefits of using enhancing in Katia? It can be used to create exploded view of assemblies. It can be used to compare different configurations of an assembly. It can be used to create presentations of assemblies, and also it can be used to save the positions of parts or sub assemblies in an assembly. Okay, so here is the process, a theoretical process on how to create an exploded view in enhanced scenes. Okay, so the figure next to the process actually says snap automatically to select object, which is the function to move the parts whichever we want and how the distance of the parts we would like to extend. Okay, so here is the example of our product which we have created the exploded view. So here is there's a nut, the fan, all right. Then there's three screw, fan case which attached to this area, fan motor, and also the nuts. We have arranged and set the distance using the enhancements in Katia. So here is the look of our products, okay, which is the proof of we have done the kinematics uh, using the revolute join command. All right. So in this setup, in the dialog box, we set the coincidence for the fan blade and fan motor. Okay, and also the plane. We set the fan motor and the fan blade because it is attached together. Okay, so here is the detail where we create the nuts in order to lock the fan motor and between the fan motor and the fan blade. All right, so we use the simulation and replay command in order to create rotational repeatedly. All right, so in order to create this kinematic successfully, we have to set the mechanism DOF equal to 0. Okay, so for the discussion, what is exactly the movable parts in this product? Alright, the part which should be moving is actually the fan blade. Alright, the objective of this project is achieved because we have done by making the fan blade moving using the kinematic. Alright, so because it in reality it is a theoretical of a radiator fan, the kinetic energy is generated from the fan motor to make the fan speed. Alright, so it is attached to the fan motor, uh, and it will be moving. Alright, so we use the DMU kinematic in digital mockup. Okay, so what type of command we use to create the kinematic is possible. Alright, so in this project, the fixed part of or the mechanism we set is the fan motor, where they will sit still and holding on to the fan blade. Alright, next is the figure of the mechanism and revolute joint command is the proof that we use. Alright, so below is the command setup, which revolute join dialog box setup. We set for the angle driven for the fan blade, and the fixed part is the fan motor. Alright. So and another is a proof where fan motor and fan blade are involved on successfully create the revolute joint command. Okay, so for the modification, alright. So actually, the whole product is actually we create our own measurement, alright. So each part and each part has we have resource which we can see, which we can learn from YouTube, alright. Other than but there's one part which we have to create by our own creativity, which is the radiator fan case. So but we still have resource for this, but not exactly the radiator fan case. Alright, so we did some research on the catalytic converter. Alright, because before this we have another project related to catalytic converter. So we adopt a technique and idea that are almost identical to manufacturing of the catalytic converter on YouTube. So this radiator fan case was intended to close resemble the original thing in appearance. Okay, like I said before, the relative cache, we use the same technique and same idea, but it is almost not the same look like the catalytic converter, right? So we use the generative shape design in order to create the relative case, which is as you can see in the next figure. Alright, there's a yellow surface, right? We use the surface design, alright. So by after creating the surface, alright, we use this thick surface which to create outside thickness up to 5 mm. So thickness of wall of the fan case is 5 mm. Right, then we completely design the project dimensions and use all available resources as a guide to help us accomplish its goals. So basically, the radiator fan case design we follow the design like they exactly closely mimic the original product of the Pro 2 Myvi. Alright.